So rational x to the 5 variable raised to a power. And how you solve this one is there is a exponent rule that if I got an exponent raised to a power, then I'm going to multiply my exponents. Okay, so whatever they are. So we're going to use this rule. And we're also going to use the algebraic rule that what you do on one side, you have to do on the other. So I'm going to take my x to the 5/4, and I need to raise it to a power that's going to cancel out my 5/4. It's going to give me an exponent of 1. And so what we do is that we're going to change colors, and we're going to raise it to the power of the 4/5. We're just taking the reciprocal. Okay.
Yeah, about the same thing essentially.
Well, we're the reciprocal of x. Everybody in?
What is that reciprocal now?
It's the opposite.
Yeah, it's the opposite. You're just flipping your fraction.
Okay.
Okay, so
it's going to always be a fraction?
it's a, yeah, because most of the irrational exponent is a fractional exponent.
Oh.
Okay, so you're going to take your fraction and you're going to flip it. And of course, with the rules of algebra, whatever you do to one side, you have to do to the other. So I'm going to take 32 to the 4/5 power also. One of these days I'll get used to this. So the 5 cancels the 5, the 4 cancels the 4, and I'm left with just a power of 1 here. So I have just x. And then if you remember back to a couple of weeks ago, maybe I did this a couple of weeks ago, when you have an exponent as a fraction, it's your power over your root. That's a fractional exponent. So this would be like x is raised to the power over the root. So with my 32, I've got a root of 5, and I got a power of 4. So I'm going to take the 5th root of 32, and then I'm going to raise it to the 4th power. Okay, so I'm just breaking out my root, or breaking out my fraction, and putting it back into just simpler form.
Is this where the 5 is like the index or something like that?
It's
The index, the radicand, and then the something else.
The 32 is the radicand, the 5 is the index, the symbol is the radical, and then of course the 4 is the exponent. All right, so the 5th root of 32, and you can put this in your calculator. Depending on the calculator you have, if you're using the phone calculator, it won't work. But you can do a 32, a caret key, and then a 1 divided by 5. And that works in a TI-83 and a TI-84. It works in my little blue and white calculator if I knew what I did with it. You can also take 32, and we can take it down to prime numbers. 2 goes into 32 16 times. 2 goes into 16 8. 2 goes into 8 4. 2 goes into 2 2. And I have 1 2 3 4 5 2s. So that equals 2 to the 5th. So the 5th root of 32 is going to be 2. And I'm going to raise that answer to the 4th power. Okay. And then 2 to the 4th power, just do 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So then x is 16. It's really not. It can be complicated. There's a lot of steps. We'll look at it like that way. but it's not hard, it's just remembering the steps. Now, I'm going to teach you the process because in case, we'll get into some situations where we'll need to know that the top number is the power, the bottom number is the root, because we'll have to do some things with it by hand. But if you're just wanting to simplify or wanting to know what the value is of 32 to the 4/5 power, so if I come down here, I'm going to change pen colors. So if I come down here to 32, and I just want to know what that value is. If you've got a TI-83, a TI-83, a TI-84, or I don't know what the Casio numbers are, but any of them that you can do exponents with, do 32, do whatever your exponent key is. I use the caret key because I'm a Texas Instrument person. Then in parentheses, do 4 divided by 5, 4/5, whatever it is. And it will give you 16. Okay. So if you ever just want to know the value, you can do that in your calculator. So let's do another one of these. Let's do x to the 3/2 equals 25. So we're just going to take our x. I've got a fractional exponent. So I'm going to multiply it by its reciprocal, and I'm also going to take the 125 to the reciprocal. So that means I'm going to take the 3/2 to 2/3. 125, I'm going to take it to 2/3. Because what I do on the left, I have to do on the right. Okay. So then I will have x, because this all cancels. Or I could say, you multiply it out and you'll get 6/6, but 6/6 is 1, right? 6 divided by 6, that gives me 1. And then I'm going to take the 3rd root, 125, and I'm going to raise it to the 2nd power. The cube root of 125 is 5. It's 5 times 5 is 25. Times 5 is 125. And then I'm going to square my 5. And I get 25.
How do you know what goes in the index?
The bottom number.
The bottom number.
The bottom number.
Before you flip it?
After you flip it.
After you flip it.
Mm-hmm. So you like the word index, so I'm going to go put index under here. So that's your index.
Just because I just learned it yesterday.
In science, no less, probably.
Actually,
Chemistry or
the math reasoning.
foundations.
Yeah, I got there, so I'd use my new vocabulary.
Okay. No worries.
It's better than calling it the little thingy.
Yeah. I just call it the root. Because it is the root. But you realize I'm used to teaching high school, or I've taught college almost as long as I've taught high school now, but first 13 years I taught high school students. They weren't big on the vocabulary.
I'm not either. That's
they
why I use it.
They want it in layman's terms, so I try to use layman's terms. Try to throw the vocabulary in there too.
Miss Young.
Yes, ma'am.
So with the 125, how do you know? I'm not sure if y'all said this, but how do you know it's 5? Do you find a number that go into that evenly or some sort?
Yeah, I'm going to take it, and if I go over here to the right and I break it down, I got the 125. It ends in 5, right? So I know it's going to be divisible by 5. So 5 into 20, or 125, 25 times. Then 5 goes into 25, 5 times.
But let's just say we didn't know. So how do we find 5?
Well, you could start out with a calculator and doing 125 divided, well, you know it's not even, so it's not going to be divisible by 2. So you could do 125 divided by 3. That will give you a whole number. So yeah, if you're looking for whole numbers, and you're looking for prime numbers pretty much.
Okay, got it.
So you start dividing. All right, so we're going to change it up just a little bit. This one, we're still dealing with rational exponents. I have to move my paper up. Okay, so, whoops. Let me try this again. Same problem. I'm going to write it better. So I have 3x to the, all right. When you're first learning new software or new, whatever this is, software, you have problems. I gotta let somebody into. So I have 3x to the 3/4 equals x to the 1/2. All right.
Well, we just flip both of them, or just flip one and then apply.
Well, actually, we can't even flip either one of them right now. Okay. We're going to get it to the point to where we can flip it. All right. But I've got, well, maybe we won't flip it. But anyway, I've got an x on both sides. So I've got to get the variables on the same side of the equal sign. So, and this is called solving the equation involving rational exponents and factoring. So I'm going to move this x to the 1/2 over here, so that I have 3x to the 3/4 minus x to the 1/2. When I move it across the equal sign, since it's positive here, moving it across makes it negative. It's the same thing as subtracting from both sides.
When you want to combine.
Okay. Well, I can't combine them because one of them has a 3/4 exponent, one of them has a 1/2 exponent. It's like saying x squared and x. Okay. They'd have to have the same exponent, the same fraction. What I do need to do is I need to be able to factor these, to factor an x out, do a greatest common factor. In order to do a greatest common factor, my two fractions have to have the same denominator. Yes, sir.
Did you not just make it 0/4?
That's what I'm fixing to do. But it still would be the same. So to get the common denominator, which is going to be, have a denominator here of 4. So I got to multiply the bottom by 2, have to multiply the top by 2. Black pen, here we go. So I'm going to have 3x to the 3/4 minus x to the 2/4 equals 0. Now I can take an x out of both of these, and I can take an x to the 2/4. Okay. Let me scoop this up. So when I do that, that's the same thing as dividing each one of these by x to the 2/4. When you're factoring, you're dividing each term. When I divide the x to the 3/4 by the x to the 2/4, I'm subtracting the exponents. So when you're dividing variables, you subtract the exponents. So 3/4 minus 2/4 gives me x to the 1/4, right? So, and I've still got this 3 on the outside. I haven't done anything with him. Now, when I divide x to the 2/4 by x to the 2/4, what am I left with out here? We take away the 2/4 and not even worry about them. What's x divided by x? 1. So I'm left with a 1 here.
Is that 3x to the 1/4?
Yeah, 3x to the 1/4 minus 1, and they all equal 0. And if you'll remember back when we were solving quadratic equations, and they were equal to 0, we factor, set them equal to 0. We're going to set our factors equal to 0. It's supposed to be 2. So x.
You have to divide the 3x and the x by 2/4.
Yeah.
And that's how you got the 1/4. Gotcha.
Yeah. And then I'm going to take the 3x to the 1/4 minus 1 equals 0. And so we're kind of combining what we did with quadratics and what we're doing with the exponents. Now, it doesn't matter what our exponent is when it's set equal to 0, because 0 to any power is still 0, right? So with this one, x to the 2/4 equals 0. Well, just for sake of following through with my pattern here. One pen, I'll change colors. We're going to flip this to get just x. So I'm going to flip it to the 2/4. So I got to take my 0. I'm sorry, my 2/4 to the 4/2. So I got to flip them both. All right. So this cancels. I'm left with x. Well, what is 0 to the 4/2 power? 0. So I've got 1x, it's going to equal 0. All right, and then I've got the 3x to the 1/4 minus 1 equals 0. So I'm going to add 1 to both sides. So 3x to the 1/4 equals 1. Then I'm going to divide it by 3 because I want x by itself. Sometimes I can write normal size and sometimes I write great big. All right, so 3 divided by 3 gives me just x to the 1/4 equals my 1/3. Okay, so now I'm right back to kind of like where we started with the first example.
How'd you get 1/3?
When you divide both sides here, I got to get rid of this 3. So I got to divide both sides by 3.
Oh, so does that equal 1 right now?
Yeah, I'm going to rewrite that.
That's what.
Again.
Oh, yeah, because we added the 1. Okay, gotcha.
Yeah, we added the 1 to both sides. I'll have 1/3 here. All right. So I'm going to take this side. So I flip the 1/4 again, making it 4/1. This one's 4/1.
Just flip it over each time. Like throughout the problem.
Once I flip it on the left, I just multiply the same number on the right. I don't want to keep flipping it. I'm only going to flip it once. So 1/4 times 4/1 gives me 1. And then I've got 1/3. So what's 4/1? The same thing as just 4, right? So 1/3 to the 4th power is the same thing as saying 1 to the 4th, 3 to the 4th. So 1 times 1 times 1 times 1 is 1. 3 to the 4th would be 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So then my answer is x equals 0 and 1/81. Now that one's a little more complicated because we're factoring. We're doing a lot of things. Let's look at something different. I can't draw a straight line to save my soul either. Do you remember the square root property? We're going to do something similar to the square root property. I have x plus 5 to the 3 halves equals 8. It kind of looks like this. But I've got the fractional exponent. That means that I'm going to take, and I'm going to flip the 3 halves, make it 2 over 3. Then I'm going to take and make it 2 over 3 here. The 3's canceled, the 2's canceled. And I'm left with x plus 5. So now, and you can do this in the calculator, or you can do the cube root of 8, that's the index, and we're going to raise it to the second power. I'm going to keep my x plus 5. The cube root of 8 is 2. Raise it to the second power. Now, I don't have to, when we did the square root property, we had to do the plus or minus. I'm doing a cube root, so it doesn't matter. As a cube root, I can take the cube root of a negative number and I can take the cube root of a positive number. So I don't have to do a plus or minus here. So I have x plus 5 equals 2 squared, which is 4. I'm going to subtract 5 both sides. So x is going to equal -1.
So you square rooted the 8 and I got your 4 or 2.
I cube rooted the 8 because the 3 was on bottom. 3 is my index. So I'm taking, what goes into 8 3 times. So I have 3 2s, so it's 2 to the 3rd. So the cube root of 8 gives me 2. And then since my top number was 2, I'm going to raise that 2 to the second power. That gives me 2 squared, which is 4. Okay. So questions? Not till you do the homework anymore, right? Or do some extra problems. All right, so we're going to move from that to looking at polynomials. And polynomials is any expression to the nth power. And they give a polynomial as a to the nth, x to the nth. So I've got any lead coefficient, which of my first term, and x to my highest power. Then it's plus x or a to my n minus 1, which is my second lead coefficient or second coefficient, x to my next lowest power. Okay? And this goes all the way down. You don't have to worry about, I'm just kind of giving you an idea here. You don't have to worry about remembering all this because this can be quite long. So it goes down to the next to the last lead, or next to the last coefficient, next to the last x, last coefficient, the last x, and then my whole number. Okay. Now we're used to looking at, like say, maybe 3x squared plus 2x plus 5. That's a polynomial. That just has a special name. That's called a trinomial, but it's still a polynomial. Okay. You know, it has a lead coefficient of 3, highest degree of 2. It has 3 terms.
The only thing that changes is the highest degree. The highest degree as you go on.
Yeah.
If there's more than 3.
Yeah, we could have one that's like,
Maybe like cubes.
we could have 78x to the 9th, or x to the 29th even, plus say 62x to the 7th, plus 45x plus 3. So I don't have to have a variable for each descending power.
So that's just telling you to put them in order?
Yeah, it's just telling you that this is, you most of the time you're going to have the polynomial in descending order.
I learned this history as well.
Good, it sounds like Miss Wilson, or do you have Miss Wilson?
I'm not sure. I think it's Gregory.
Mr. Slade? He's a big stickler on terminology.
Oh yeah, I didn't do good on the test. That's why I remember it so well.
So, but at least we're on the same area here. But yeah, it's just going to be in descending order is all it is. Number in front. So we can have any number in front. We can have any power. We can skip powers in between. So, those are just polynomials. You're going to see a wide variety of them. As long as it's a guide, and it may not even have a number. You could have x to the 13th plus x to the 12th plus x plus 5. Y'all, your lead coefficients are 1. So, it can be any variety as long as it's in, and if it's not written in descending order, you want to write it in descending order.
You stand to the degree is right.
Right. The descending order is by degree. All right, so we're going to get into solving the polynomials, just like we did solving the quadratics earlier. So I got 5x to the 4th equals 80x squared. So just like I did with the fractions a while ago, I want to get my variables on the same side. I want everything on the same side. I want to set it equal to 0. So I'm going to either subtract 80x squared, or I'm just going to move it over and change the sign, however you want to look at that. So 5x to the 4th minus 80x squared equals 0. And then I'm going to factor, find my greatest common factor. So what number goes into 5 and 80? 5. And then when you're factoring, it's always your lowest power, okay? Or my lowest, smallest exponent. So I'm going to take out, oops, put that parenthesis too soon.
You do too.
So I'm going to, x squared. So again, I'm basically dividing both of these by 5x squared. Okay, I'm not good enough to write the 5x squared in there. So 5 divided by 5 gives me 1. X to the 4th divided by x squared, so I'm doing 4 minus 2. I'm left with x squared, right? Minus, so what's 80 divided by 5?
Eight.
16.
16. Okay, thank you. I was going to do it over here.
No, I don't know. I was guessing.
Yeah, 16.
Yeah, 16. I'm not doubting her. I just started to do this, so I'm doing it. So x squared minus 16 equals 0. Okay. So I'm going to set both factors equal to 0. So I'm going to have 5x squared equals 0. And then I'm going to have x squared minus 16 equals 0. Now, there's something special about that x squared minus 16. Does anybody recognize what's special about it?
Yeah, perfect square.
Almost.
That was another guess.
Almost.
You can make conjugates.
Yeah, I can make conjugates, but it's not in the denominator, so I don't need to do that. But I could. But I can factor it, and it's a special factor. You're in the right ballpark with perfect square. It's the difference of two squares, okay? So I can take, and basically to do the difference of two squares, I take the square root of the first term, which is x, right? So x and x. Then it's minus, and it always has to be minus in order for this to work. So one factor is plus, one factor is minus. Then I take the square root of 16. Square root of 16 is 4. So that's my second term. So x plus 4, x minus 4 equals 0. And then I've got to set both of these factors equal to 0.
They just flip.
Mm-mm.
Or
Well, yes and no. It depends on how you want to look at it. They're going to change signs, if that's what you mean.
yeah, they would just change signs, but
Yeah.
you don't have to.
Which the x plus 4, x minus 4 is conjugates, right?
Yes. Okay, I see where you're getting conjugates at now. Okay, I call it, when I'm factoring, I just call it the difference of two squares. But yeah, it is, they are conjugates. You're absolutely right. All right, so I'm going to move my 4 over, so I have x equals -4. Move my -4 over, so I have x equals +4. Now, I can't forget about this 5x squared equals 0. And if I want to technically, I want to divide both sides by 5. So I get x squared equals 0, right? Because 0 divided by 5 is 0. Well, if I do the square root of x squared, do the square root of 0, square cancels the square root.
X equals 0.
Yeah, what's the square root of square root of 0 is 0. So now I've got 3 values of x. I got x equals 0, x equals 4, and x equals -4. I wrote them different than what I've got showing.
And that's how you lay it.
Yeah.
Do we need to check these when we get done?
You can for your own benefit, but you don't have to for me.
Okay.
To check them, you're just going to put those 3 numbers one at a time back into your original, always go back to the original problem
In place for the x.
in place for the x.
There's not going to be any extraneous answers, is there?
There shouldn't, well,
What does that mean?
Don't ask me right now. Because I know what she's talking about, but to put it in words right now, can't do it. There shouldn't be any extraneous answers on this,
Okay.
okay? Wait a minute. Yeah. There will be on some of this other, but not on this.
Okay.
Okay. And to give you a little more idea about what these 4 answers mean. Yes, sir.
If there's an x on both sides, wouldn't 0 equal x every time? Because 0 times 0 equals 0.
You talk about the 5x squared equals 0?
Yeah,
Or-
up here at the top, wouldn't 0, if there's an x on both sides, wouldn't 0
Yeah.
be 1 every time?
Not every time. There's some instances. Well, yeah, I guess you're right. A 0 would be 1 every time because I'm going to have a greatest common factor of an x squared or an x. So yeah, if you've got an x squared equals an x even, you'd still get, a 0.
That's true only if there's 2 terms though, right? One on one side and only 1 term on the other side.
Right. Only if it's terms.
If anything was added, then it would change. It would change.
Right. If I had a whole number here, if I had a constant, it would change it.
Yeah.
And I wouldn't have a 0. But it has to be a single term on the left equals a single term on the right.
Yep.
And then every time you would, as long as there's a variable, an X or a Y, both of them Ys, both of them X's, the same variable, then you would have a 0 each time. Y'all are making me think outside the box today.
I'm just,
But that's good. Yeah, that's good. Asking questions and making me think. I like that. All right, so to give you some idea, if I was to graph, and, you know, I can't draw, but what I would do is I'd graph these 3 points. So I'd have a point at 0. I'm going to call this -4, and I'm going to call this +4. I mean, there's a lot more that goes into this, but this graph, since I've got the +5 here, it's going to start up here in the positive. It's going to go down through here, back up, and it's going to touch 0, back down, and graph. Whoops, it's supposed to go through that 4. But that's something about what the graph would look like with 4 terms. Kind of an upside, or kind of a weird W type thing. Okay, but these values that we're finding for X, there are X-intercepts of polynomials. Okay, so it's where the X either crosses the line crosses the X-axis, or it touches the X-axis. And since, you know, I did the square here, I have X squared equals 0. This means that I'm going to have, oh crap, that word just went, when we do the graphing on these, I'll think of that word. I can't think of it at all right now. But it just means that 0 is going to touch the X-axis. Okay? And so technically, since that's a squared, I would have 2 zeros here. All right. Do I need to do another one of those, or are y'all okay with this? The process. Right now you get it, but when you get home, will you still get it? Maybe. Maybe not. All right. Let's look at something that I hope is a little more a little easier, maybe. We have the polynomial x cubed plus x squared minus 9x minus 9 equals 0. And I want to know what x equals. What are my values of x? If I was to graph this, where would my line cross the x-axis? But there's 4 terms. So I can't just, and there's not a greatest common factor of all 4 terms. So remember when we were doing the AC method and we did some grouping, we did some factoring by grouping, where I grouped the first 2 terms together and I grouped the last 2 terms together, and I took a greatest common factor out of both terms. Does that ring a bell at all? Y'all have slept since then? Get it? All right, so,
Yes.
all right, somebody remembers. That's good. Or somebody slept since then. That's okay too. So what we're looking at is we're going to group, when you got 4 terms, you can put them in pairs. And you're going to find the greatest common factor out of the first 2 pair and the greatest common factor out of the second 2 pair. And sometimes you have to rearrange them. Yes, sir.
Does the minus go with the minus 9?
Mm-hmm. The sign in front of it always goes with it, even though I don't include it in my bracket. So if I look at the first 2 terms, I can take an x squared out, right? So I divide the x cubed by x squared and I get an x. I divide the x squared by x squared, and what do I get?
0.
1. Because remember, we're doing x squared divided by x squared, so it's like saying 2 divided by 2. It's going to give me 1. And then, since my 9x is negative, I want to factor out a negative. regardless if both of them are negative or not, I want to factor out a negative. And these both have 9s. I factor out a -9. And then I'm going to have x plus 1, because -9 divided by -9 gives me a +1. Okay. So now this x squared times the x plus 1 becomes one term. The -9 times the x plus 1 becomes a second term. Okay. So out of those two terms, my binomial is the same. So I can factor out an x plus 1. So what I'm doing is I'm going to change colors. Is I'm dividing this by x plus 1, and I'm going to divide this term by x plus 1, so that my binomials cancel. Okay, because I've got two terms, greatest common factor is the binomial. That's the weird part of this one.
You get the same things in the parentheses each time. It wouldn't be something separate.
If you get something different in your parentheses, then go back and reevaluate your greatest common factor.
Okay.
Because the whole idea is to get the same binomial.
So that it can cancel, or to be able to
Get
divide.
factored out, yeah. And then I'm left with x squared minus 9. I'm left with this number and the x squared. So I don't want to ignore my x plus 1 out here, but I want to look at my x squared minus 9. Okay.
How do you keep the x plus 1?
Because when because instead of, okay, the idea is that I'm dividing it out, but I'm also factoring it out.
Still keeping it?
So I'm keeping one of them because it's coming out of both of them. If I was to multiply it, distribute it back to the x squared and back to the -9, then it's like I'm undoing my distributive property. Okay. So the x squared minus 9. It's the same thing as what that x squared minus 16 was a while ago. It's a difference of two squares. Or we use the conjugates.
So it would be just x minus 9 and x plus 9?
Not 9. What's the square root of 9? 3. So you got to remember to take the square root of both terms. So x plus 3 and x minus 3.
Just the x squared on the x.
Right. So it's x for the x squared and 3 for the 9. And then we're going to set each one of these terms equal to 0. And I'm going to subtract 1. So I get x equals -1. Subtract 3. Get x equals -3. Add 3. I get x equals +3. So then my values of x is -1, -3, and 3. Okay. Now, I haven't looked at the homework. I don't even know if I've got homework for this one in Canvas or not. But I will probably, if I put it into Canvas, if I haven't got these or I've already got them, they're probably in order, numerical order. So in Canvas, it's probably -3, -1, +3. Okay. So if you put -1, -3, +3, and they're just different order, can't count it wrong. But I go in and I'll give you credit because you got the right values. Okay. Because how many different ways can we write -1, -3, and 3? You know, there's several.
Or like you space out one.
Yeah, or if you put the spaces and don't put the spaces and all that. So, but as long as you got the right values, you will get credit for it. So don't freak out if it counts it wrong. That is, if I even put this homework up and not just give you a group homework for something. All right. How much time do I got left? Not a whole lot. So we'll leave that there. And then we're going to move on And this is typed other equations, so there's several different types of equations that we're looking at. And this is called a radical equation. And that means that I'm using a radical. So I have 3x plus 18 equals x. Okay? And the whole goal of this one is to get rid of, or the first step, I should say, is to get rid of the radical. Okay? Whether it's the square root, cube root, fourth root, 10th root, 100th root, whatever, we've got to get rid of it.
So what do we just square root both sides?
Not square root. How would you undo a square? I mean, how would you undo a square root? What can you do to it to
You square it.
square it? So you were in the right process. So what I do to the left, I have to do the right. So if I square the radical, I have to square the x. So my square cancels my square root, and I'm left with just what's underneath over here. And then it's equal to x squared.
Would you put it all on one side now?
Yeah, now I'm going to move it all to one side, but the key is you want the positive x squared. Because anytime you've got an x squared, you've got a factor. I mean, anytime we're doing this, we want the value of x, we're going to factor. So I'm going to move my 3x over, making it a negative 3x. Positive 18 over, making it a negative 18. So I'm going to have 0 equals x squared minus 3x minus 18. And then we go back to what we were doing with the quadratics, because I have x squared is a quadratic. So I've got a factor. So I've got an x squared, so I know my first factor is going to be x and x. Then I want to know what's my factors of 18 that's going to multiply to be, or that's going to, what are my numbers that are going to multiply to be 18, negative 18, and add to be negative 3. So it's multiplying to be the end term, adding to be the middle term. Negative 6 and positive 3. Negative 6 times 3 gives me the negative 18. Negative 6 plus 3 gives me negative 3. So I have x minus 6 and x plus 3.
And then would that just be the answer?
No,
Or no, you gotta set them equal to
I
0.
set them equal to 0. I'll look over here. So if I have x minus 6 equals 0, I add my 6. So x equals 6. I have x plus 3 equals 0. Subtract 3. And x equals negative 3. So then my values for x, negative 3 and positive 6.
That was probably this one we did all day.
Probably. Right. Still staying with, I guess you'd say this thing. I have the square root of x plus 3 equals 3x minus 1. We're going to do the same thing. We've got to get rid of this radical before we can do anything else. And since it's a square root, I'm going to do what again?
Square it.
Square it. And then I'm also going to square the 3x minus 1. So the square cancels the square root. I'm left with x plus 3. Now, when we square the 3x minus 1, that's the same thing as saying 3x minus 1 times 3x minus 1. I'm not just squaring the first term and squaring the second term. I'm multiplying that binomial by itself. I'm going to keep the x plus 3 over here. And I'm going to FOIL this out. 3x times 3x gives me 9x squared. 3x times negative 1 gives me negative 3x. Negative 1 times 3x gives me negative 3x. Negative 1 times negative 1 gives me positive 1. Then I'm gonna combine my like terms and kind of clean it up a little bit, make it look neater. So 9x squared, negative 3x gives me negative 6x plus 1. Just like we've done with everything else. We gotta get everything on the same side of equals. You gotta get it equal to 0. So I'm gonna move my x over, so I'm gonna subtract x, but I gotta subtract it from my x, right? I'm subtracting 1x. I'm gonna subtract 3, but I've gotta subtract it from my constant. So I've got 0 equals the 9x squared, negative 6x minus negative 1x gives me negative 7x. 1 and negative 3 gives me negative 2. And then I have to factor this puppy. So do we want to do the AC method, or we do want to try the trial and error method? Or do we want to do the quadratic formula? Trial and error? Okay. If y'all don't want to do trial and error, y'all do whatever y'all want to, but I'm going to do trial and error. So since I have 9, I'm going to start with 3x and 3x.
It's going to be 9.
Is it going to be 9? She's already got there. Okay. Take my fun away. 9x and x. And then
1, it'll be 2 on this side, on the left side over here, and 1 over
positive 2 and minus 1?
Yeah.
Because I do 2x, and then 9 and negative 1 gives me negative 9x, that gives me negative 7x. So that works.
I'm confused. That's because I don't do the trial and error yet.
Do whatever method you're comfortable with. So now I'm right back to where I was earlier. We saw set them both equal to 0. X minus 1 equals 0. So we're going to solve both of them for x. Divide by 9. X equals negative 2/9. Add 1. X equals 1. So negative 2/9 and 1. Are your minds blown yet?
As much as I could. I definitely want to break.
All right, I've got one more equation to show you. Actually, there's 2 more, but I'll save one of them until next time. So all right, so if I take the absolute value of 4, I think we did this with the square root property. We talked about it. No, it was the square root. If I take the absolute value of positive 4, I'm going to get 4, right? Because the absolute value is always the positive. What if I take the absolute value of negative 4? What am I going to get? 4. Okay. So the absolute value of a positive 4, the absolute value of a negative 4 is they're both positive 4s. So if I have a problem that says, okay, the absolute value of x equals 3.
The x equals 3.
Well, x will equal 3, but could x also equal negative 3? Because what's the absolute value of negative 3? 3. Okay, So if I was to take and put a -3 in here for x, the absolute value of -3 is still 3. So x can equal a +3 or a -3.
What if the absolute bars was on the 3 inside the x? What does that do different?
So if I had something like the absolute value of 3 equals x, so what's the absolute value of 3? 3. So x would equal 3.
It would be -3 as well.
No.
That don't happen until it's on the x.
It only happens if the x is inside the absolute value. Okay? Now, I did all that because we're looking at absolute value equations. So if I give you the absolute value of 6x plus 4 equals 8. Okay? The absolute value will always equal 8. But what I want to know is what is x without the absolute value bars?
We have to make that equal 8.
So we're going to set it as 6x plus 4 equals 8. But this could, inside here, could equal a +8, right? Could inside this also equal a -8? Okay,
There used to be 2/3, though.
probably. I'm gonna work it.
So make it 4 plus 4.
Okay, getting ahead of me here. All right, so I'm looking at, let me. Go back to my beginning. All right, I'm looking at just this right here. All right,
Without the bars included.
without the bars. We know that the absolute value of 8 equals 8. The absolute value of -8 equals 8, right? So okay, let me go back here. Let's keep the absolute value bars intact. Let's look at it as the absolute value of 6x plus 4 is going to equal the absolute value of +8. That's already given because that's my equation, right? And then let's look at it as the absolute value of 6x plus 4 will also equal the absolute value of -8 because the absolute value of -8 is +8. Okay? So we're going to look at these two equations, both of these. I'm going to call this equation 1 and this equation 2, because whatever x is, x is going to be one number that's going to come up with a +8 inside. It's got another number that's going to give me a -8 on the inside.
So we're going to try and plug in a number for x to make it equal 8.
We're going to solve for it.
Right, you go ahead then. I'll say I figured it out.
Let me. Okay, I'm going to do number 1 in red. So I'm looking at the absolute value of 6x plus 4 equals the absolute value of +8. Okay, so what I'm going to do is I'm just going to drop all the absolute values and solve for x. So 6x equals 8 minus 4, because those cancel. This 4 divided by 6. And so that reduces, like you said, to 2/3. So x can equal 2/3. When x equals 2/3, then it's the absolute value of +8. So let me go up here, change my pen color. Let's go to green. So we'll do number 2 in green. If I take the absolute value of 6x plus 4 equals the absolute value of -8, because the absolute value of -8 is still +8. Mark it just like I did the other one. Drop all the absolute value bars. So now I have the 6x plus 4 equals -8. I want to subtract 4. The x is canceled. -8, -4 is -12 divided by 6. So x equals -2. So there's two different options for x. Okay.
So they're both equal to those.
So I'm going to check them. So if I check this one, and I'm checking the 6x plus 4 equals +8. So I always want to go back to my original to check. So I'm going to put 2/3 in for x. So 6 times 2/3, 6 times 2 is 12. Divided by 3 is 4. So 4 plus 4 equals the absolute value of 8, which equals 8. Okay, so that one checks. Now, to check my green one. And again, I'm going back to my original because it has to check in the original. So I want it to look equal just +8. So this time, I'm going to put -2 in for x. 6 times -2 is -12 plus 4. -12 plus 4 is -8. The absolute value of -8 is +8. So this one checks. So then x has two answers. X can equal 2/3, or it can equal -2. Okay. So with an absolute value, x can equal two different numbers. That one was easy.
Yeah, I'm sorry, something in my head didn't add up.
I mean, I've gone over 5 or 6 different types of equations in this last hour and 20 minutes, or 10 minutes, whatever. So yeah, it's a lot to comprehend. So I'm going to finish up the absolute value next week. I have to make myself a note in a minute. And then see if I can't get something on paper. But what I would like for you guys to do, everyone to do, is to go in your textbook in section 2.6 and work some of those problems. Work the odd problems. You don't have to work every odd problem, but work the odd problems that match up with some of the examples we did. Get you some practice in. You know, you can go in. I'll have to set the home page back again where you can have the link to the online textbook. But you can go in and into the online textbook and you can find those problems. Okay. All right. So questions? All right. I will see you next week. Have an enjoyable weekend.
Okay, bye.
Bye.
I think today was the most comprehensive day I've had.
How come Mark was not on campus?